that we do this sampling again and again and again, then the sample mean will also follow the normal distribution. So here, it is all the possible values of sample means. And we will have another normal distribution for the sample means, and this in the middle is the mu of the mean of a sample mean, which is actually mu. And by the 68, 95, 99.7 rule, we know that all the sample, 95% of all the sample values will lie between mu plus 2 sigma and mu minus 2 sigma, which is sigma of sample population of the sample mean, so which is mu plus 10 points. This is mu minus 10 points. So we know that 95% of the time when we choose a sample of size 16, the value would lie between the true mu minus 10 points and the true mu plus 10 points. Therefore, for each of this value here, what if we expand it? Instead of just giving it a value in the middle, we say for each of them we plus 2 standard deviation and subtract 2 standard deviation, right? And then in that case, we are looking at something like this. Let me copy this graph here. And then let's say x1 is actually here. And then we use x1 plus 10, x1 minus 10. And let's look at this interval. It happens to capture mu here. So this tells us that if we use x bar 1 and plus 10 and minus 10, this interval will actually include the x mu. Likewise, if we have, let's say, x2, if x2 is here, x2 bar is here, and then x2 bar plus 10 and x2 bar minus 10 would also cover this true mu. What if we are unlucky to have some x bar 3 that's far away from that, and even with this x3 bar plus 10, x3 bar minus 10, the true mu is not covered. So since all those mu's, all those x bar could happen anywhere, so sometimes it's covered that, sometimes it's not covered, right? So we can also move to the left, move to the right. So this x bar could be anywhere, but sometimes it's covered, sometimes it's not covered. But what our goal is to find, we want 95% of the time, this interval x bar plus 2 sigma x bar and x bar minus 2 sigma x bar covers the true mean here. So when this happens, we say that we are this interval is the 95% confidence interval. So for example, if we somehow calculated that the 95% confidence interval, for example, is from 230.79 to 250.79. That means that we would be using a method that captured the true mu in about 95% of all possible sample of this size 16. Okay, and the last 2 digits of today's class attendance code is IN.